I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic on current and current density, and also we are going to see the continuity equation and point form of Ohm's law. So, the current and current density. We know that electric charge in motion constitute an electric current. In metallic conductors, the charge is carried by electrons, but in liquid conductors, the electrolytes, the net charge is carried by ions, that is positive or negative. In semiconductors, the charge is carried by electrons and holes, the holes behaving like positive charges. So the flow of charge per unit time, or we can say the rate of flow of charge at specified point or across the specified surface is called electric current. So the electric current is given by time rate of change of charge, that is dq by dt. It is measured in coulombs per second or amperes. So, due to the movement of free charges, several types of electric current can be caused. One is called conduction current. So, this is due to the drift of electrons and holes and occurs in semiconductors or conductors. And another type of current is called convection current. Here, the motion of ions gives rise to electrolytic currents, and the convection current results from motion of electrons and or ions in an insulating medium such as liquid, uh, gas and vacuum. And current and current density. So while in dielectrics there can be a flow of charges. So under the influence of electric field intensity, we have the current is called displacement current or the convection current. And the current density is a vector quantity, and it is denoted by the letter J, measured by the unit amperes per meter square. And the current is related with current density by the formula I is equal to surface integral of current density dot ds, that is dot product between current density and surface, and it is here the current density is ampere per meter square. And the continuity equation, it says the continuity equation of a current which is based on the principle of conservation of charge. That is, the principle state that the charge can neither be created nor be destroyed. We know it is conservation of charge. So considering a closed surface S with a current density J, then the total current I across the surface is given by the formula I is equal to closed integral over the closed surface J dot ds. So the current outwards from the closed surface. So it has been mentioned earlier, the current means to flow of positive charges. So the current I is constituted due to the outward flow of positive charges from the closed surface S. And I can also be written as integral of J dot ds, or it is equal to dqi by dt, and this is integral form of continuity equation of current. And we have another important expression, integral over the surface J dot ds can also be equated to volume integral of del dot g dv. Here rho v is called volume charge density, and del dot j can also be equated to dou rho v by dou t, the negative sign. So here rho v is volume charge density, j is the current density. So the divergence of current density is equal to negative rate of change of volume charge density. That is, del dot j vector is equal to minus dou rho v by dou t, and this is called point form or a differential form or continuity equation of the current. So, and now coming to the point form of Ohm's law. So it says that for a metallic conductor J, the current density is equal to sigma into E. So here sigma is the conductivity of the given material. So we know that conductivity is measured per mhos per meter, And this equation J is equal to sigma E is called point form of Ohm's law. Here we note that the current density and electric field intensity both are vector form. Assessment. So current density and conductivity of a material 500 units and the corresponding electric field is 2 units. So they asked to find out the conduction current density. So we know the formula J is equal to sigma E, the conduction current density. So it is sigma and E is multiplied, the answer is 1000 units. And next question, calculate the displacement current density when the electric flux density is 20 sine of 0.5 t. So here we know that the conduction displacement current density Jd is dou d by dou t. So differentiating the d value, displacement current density value, and we get the answer 10 cos 0.5 t. Thank you.